let's take a look at equivalent ratios defined through the value of a ratio. Take a look at these ratios. Do you see any that are equivalent? Take a look at these two, 1 to 2 and 5 to 10. These are equivalent. How do I know? Well, one way we could do this is to take the 1 to 2 ratio and simply make 5 more groups of it. If we do that, we'll see that 5 groups of the 1 to 2 ratio is the same value as the 5 to 10 ratio on the bottom. But we can also go the other way around and instead take the 5 to 10 ratio and separate it into groups of 5 until we see that we have both a value of 1 to 2, making these both equivalent. But let's go one step further and find these ratios' values. Because of our last lesson, we know that the first number is talking about how many pieces there are, and the second number of the ratio is how many pieces it takes to make a whole. And we know that that's the numerator and denominator of a fraction. So these will be simply transferred over to fractions. And instead of having 1 to 2 and 5 to 10, it now looks like this, 1/2 and 5/10. Now, if we take a look at 1/2, we can't make that any more simpler than it is. There's no number we can divide into both the top and bottom. So we're going to move down to the 5/10 and notice that we can divide both the top and bottom by 5. And if we do that, we end up with 1/2, showing that both ratios have the same value, 1/2. Like so, 1 to 2 is a value of 1/2, and 5 to 10 is actually a value of 1/2 as well. What about our other two ratios we saw at the beginning, 6 to 16 and 12 to 32? Well, let's first turn them into fractions. And now let's see if we can simplify either of these. 6/16, I can put that into groups of 2. And if I do that, I see that 6 in groups of 2 becomes 3, and 16 into groups of 2 becomes 8. 3/8. What about 12/32? Can we group that into any number of groups? Yes, I think that 12 and 32 can both be divided into groups of 4, so let's do that. 12 divided by 4 is 3, and 32 divided by 4 is 8. 12/32 has a value of 3/8. Hey, look at this. Both of these fractions, which were originally ratios, have the very same value, 3/8. So once again, it looks like we have a bunch of different values here, but when we translate them into fractions and then simplify those fractions, we see that actually the first two ratios have the same value, and the last two ratios have the same value as well. The value of ratios are always going to be the same for equivalent ratios. Or another way to say it is, if two ratios are equivalent, then they have the same value. You know, let's test that theory. Here we have two ratios that are equivalent, 3/4 and 6/8. And we have their values to the right. Are they the same value? 3/4 and 6/8. Can we simplify either of them? 3/4, I can't put that into any groups, so that has to stay the same. But 6/8, I can group both the numerator and denominator into groups of 2. So let's do that. The numerator, 6, can be grouped into groups of 2, giving me 3 each, and the denominator, 8 into groups of 2, will give me groups of 4. And now I see that the ratios originally, 3 to 4 and 6 to 8, have the very same value. Equivalent ratios have the same value. A man is training for a biathlon. That means he's going to run or jog as well as bike in this race. For his training, he is practicing riding his bike a lot more than he is running. In fact, he runs 4 miles for every 14 miles that he bikes. What's the ratio of his running to biking? Running to biking. Well, he runs 4 and he bikes 14. 4 to 14. But then what is the value of that ratio? Remember, translating this into a fraction is simply finding the numerator, the total number, and the denominator, how many it takes to make a whole. Well, he's talking about running, so that'll be the numerator, and 14 miles he bikes is the total number that makes a whole, and so that's the denominator. Simply put, 4 to 14, written as a value of running to biking, is 4/14. But can we simplify or find groups of these 4/14? If we put them in groups of 2, then we see that 4 in a group of 2 is 2. And 14 into groups of 2 is 7. And so our original ratio of 4 to 14 is a value of 4/14, which is simplified to 2/7. And so the question, what is the ratio's value, should be answered in its most simplest form, 2/7. Now let's flip the question. What is the ratio of biking to running? Biking is 14 miles, running is 4, so the ratio of biking to running is 14 to 4. And what is that ratio's value? Remember before we had the ratio 4 to 14, and to find its value, we simply turned it into a fraction and then simplified to get 2/7. Well, if the value of running to biking is 2/7, what do you suppose the value is of biking to running? Because the ratio is simply flipped, we can simply flip the value as well. Thus, the value of biking to running is 7/2. Now we are told that he has run a total of 80 miles and biked a total of 280. Is this consistent with the value we figured of his running to biking earlier? Remember, our initial ratio of running to biking was 4 to 14, and that its value was 2/7. And now being told that the ratio is 80 miles of running to 280 of biking, we can see if it's consistent with that same value by turning it into a fraction, 80 280ths, and then determining if we can simplify this. Can we? Now there might be a bigger number, but 10 is something that stands out to me. I can put 80 into groups of 10 easily, and the same with 280. 80 divided by 10 is 8, and 280 divided by 10 is 28. So we have 8/28. Can we simplify it even more? Groups of 4. 8 divided by 4, 28 divided by 4. 8 divided by 4 is 2, 28 divided by 4 is 7. Does this look familiar? The initial ratio 4 to 14 was a value of 2/7. His actual running and biking, 80 to 280, has the same value of 2/7. Thus, these are consistent. So what have we learned with equivalent ratios being defined by their value? We've once again been reminded that to find a value of a ratio, we simply turn it into a fraction, and that if we want to know if equivalent ratios have the same value, we simplify those fractions until we find out if they have the same value or not, which we've learned equivalent ratios always have the same value.